Today's topics, we're going to be talking about oven profiling, making profiling efficient, safe, and easy and repeatable, specifically as it relates to bread baking. What are your goals? The difference between oven balancing or profiling your actual product. We're going to talk about thermocouples and where to put them, and then physically performing the profile for your baked goods, and then how to document and share those results with your friends and neighbors. So at this point, I'm going to go ahead and turn the controls over to your presenter today, Ray Pierce.
Good morning, everybody. Thanks for chiming in this morning. Hope you all had a nice holiday weekend. We're dealing with thermal profiling for bakers today, so let's have at it here and think of the questions that you have coming in, the ones we did answer along the way and the ones that come up as we go. So first of all, in a top-level general vein, let's look at some of the things that thermal profiling accomplishes for you here. Probably have a wide range of experience amongst you, so we'll keep that in mind as well. The first thing for bakers is that there's really two major areas of endeavor. One is oven balancing, tuning the beast, as it were. The idea of having, whether you have large, smaller shelf ovens or large tunnel ovens and several of them, oven balancing is a large part of certainly the maintenance department, and it behooves the baker to get somewhat involved in that at least, because without a properly tuned oven, you'll never get the baked goods optimization that you're after. So that's really the second area of endeavor that we'll be spending the most time on here, and that is baked goods optimization itself. So in the first one, you're profiling the oven. In the second one, you're profiling your baked goods, actual thermocouples in the dough insertion. Whatever it happens to be that you're baking, you'll find that our photographs predominantly are bread and buns, but of course if you're crackers, flatbreads, etc., same difference with the slight changes in thermocouple placement. As far as I had made an attempt to change most references to oven recipe to oven profile, understanding that of course recipe is a mix of ingredients that you're using for a particular baked good. So what that should say there is oven profile, which really is a set of control settings for zone temperatures, the individually controllable areas as you're moving throughout the oven, or the regime in a batch process for bake times, and conveyor speeds when that's appropriate, or the time spent, more to the point. So with running the thermal profiler through the process, you're helping to substantiate those oven profiles that have been handed down over the millennia there, and helping you develop new ones as well as you tweak your ingredients, which we'll also be talking about. So the idea, of course, is to assure that all your baked goods experience the required temperature transits such that arrival in all areas of the dough is as approximate as possible to each other and within your your corporation's specifications. Because after all, when you pay thermal profiling, no matter the process, helps you become more attuned to what it is you're actually manufacturing, and it can help greatly to increase yields, the maximization of your plant in terms of throughput, and waste less energy, be more efficient overall, which improves your bottom line profits. Having established, having obtained graphs, in other words, and data for all your different baked good products, then the job becomes periodic reprofiling to ensure that things are doing well. You know, you might have an oven against an outside wall, and in the wintertime you have poor lateral balance because of insulation issues or baffling adjustments. That's just not getting you where you need to be when it's freezing outside, things like that. So the idea with verification is that periodic profiling work to prove that your good results are being repeated, so your customers enjoy the same product week after week throughout the year, and also no matter where it's being produced in your larger multi-plant locations. So that's the overview. Let's get down to the shop floor here. Sure takes a lot of extra clicks. Oh, I need to be clicking here.
Well, what'd you do?
Okay. So in a more granular way, thermal profiling can help eliminate the tweak factor. Depending on the side of the fence that you're on, you'll relate to this in your own way, but things develop over the years, and the person who developed a given recipe or methodology of controlling a given oven could have retired a long time ago, yet nothing has changed in the settings. So it's a matter of coalescing everyone's expertise, especially those charged with production and carrying it out, and enabling them to a higher level to optimize the process to make more profits for their company. On the maintenance side, understanding that that's often a different group of people, but having a thermal profiling kit, you know, with the M.O.L.E type of device and thermal barrier, thermocouples, software, all of that helps once a maintenance cycle is performed, such as burner maintenance, to run a profile even empty through the oven in a down holiday cycle, for instance, or not. But in any case, you have data. You're replacing opinions with facts. And you're augmenting the color charts with actual arrival and yeast kill and gelatinization data. As you strive towards clean labeling initiatives, you're changing your product recipe certainly to go to natural enzymes from chemicals that you can hardly pronounce. So that and new product development tighten your process window making thermal profiling much more important even. And once again, controlling your process at the margins and being consistent about it does everything to improve your yields and profits. Let's talk about enzymes for a minute. It's quite a trend. It's been going on for a while, and I'm sure many of you work with an ingredients supplier to help you transition to enzymes in your recipes. Enzymes help extend shelf life, provide consistent high quality products, and I just mentioned this enables the clean labeling by switching to natural ingredients that don't have to appear on the label. All of this saves you ingredients, or should be saving you ingredients costs, but the process control becomes much more significant as a result of that. So the junction of all the constituents of your process tightens up with utilizing specialty enzymes in your products. Once again, having that time temperature profile, having the hard data, the window, as it were, into your oven is all important. And what we're talking about here is having actual data, a window in your oven. It's very characteristic. It's quite easy to tell what thermocouple was wagging in the air as compared to having embedded in a mass, that is dough insertion, down here. So we have your oven line up at the top here. Conveyor speed is reporting. The actual process window is contained within the process origin, which is where temperatures just begin to be rising. Some companies like to begin the clock, as it were, right on the shelf as it's coming into the oven, and then of course exit sometime after the end of the oven and prior to retrieving the profile rig, which we'll get into from a safety standpoint. So along the way here, these are 4 dough insertion thermocouples, and they all have taken their own speed through the process. So it turns out this aqua channel here took the longest to arrive, as it were, to reach the actual bake temperature here, this red line. And you'll see that we use that dynamic, this particular dynamic, to make our calculations with these call-outs that we'll get into with more detail, that you probably have a certain amount of familiarity with already. Our software automatically calculates all this for you. So it can save you a lot of time and training. So if you think about your baking process, especially for yeast goods, which we'll focus on here, you have proofing, you have baking, and often cooling, if not cooling, chilling and or freezing requirements. Say you're doing par-baked products, for instance. There's a lot of different versions of cooling, but it's all time and temperature to a thermal profiler. So take advantage of it. In the case of proofing, again, whether it be a batch process in a smaller operation, even a storefront, to large commercial proofers, there are various instruments available to monitor relative humidity as well as temperature in a simple, basic way. And You see a couple of solutions here as far as the standalone monitor. A lot of people are familiar with this style of unit here. We also have one that inputs into a M.O.L.E, and you would measure your high humidity proofing environment and verify that that's consistent rather than take that for granted as well. Okay. Of course, next up, so this is an example of a relative humidity profile. So you see a quick dip here as some transit occurred, or the door opened perhaps on a batch system. But there are two y-axes. Of course, time's always across the bottom, and we have a temperature axis for the blue channel, as you see called out down here, and then the red channel is the relative humidity scale here. Very basic, but then you have a database, so you have information to compare upon, statistical process control, a lot of things layered into all of this.
This is the tempering area with our mini-M.O.L.E.
Oh, and a good point that Mark points out is that you know, since you're bringing electronics into a high moisture environment, you know, electronics these days are coated, and there's not a problem there. But to get the instrument up to the environment prior to making the run, this is a so-called tempering stage prior to committing it to the run. So this is getting it from ambient up to the conditions of the proofer ahead of time for more accurate readings. So ovens, the main event. You can probably pick out your style of oven here. The first one's a roll-in rack style as compared to one that you would load individual shelves. And number 4 being a tunnel oven. They can be quite wide, sometimes for space savings, and other products like biscuit type products and even flatbreads. You might have a vertical style oven, and again, in the name of space saving, you could have a serpentine style as well. So they all have a vertical clearance, they all have a width based on the product, and the thermal profiler that you either have now or are considering are capable of traveling through all these styles of oven that you have in your plant or business. Moving on for a moment to the chilling side of your process. Once again, many applications, many opportunities for process control to further rein in your operations and have the process data qualified, as opposed to, oh, this is supposed to run from one end to the next, and it's retrieved and it's good to go. But in terms of energy savings, in terms of throughput, line optimization, and profits, profiling will help get you there. So when you think about setting out to do a thermal profile, you know, you have your oven, certainly. You have the product that you're going to set out. Well, today I'm going to profile this line over here. How many, what types of equipment do you need to carry all this off? So first of all, your product. Certainly in the line that you're going to run it in, Your ultimate goal may be to profile the same product running through different ovens, or to transfer, say you needed, your job was to transfer a product that's run in batch ovens in rotating shelf oven. Your volume has increased, business is good, and you want to transfer that to a tunnel oven. There'll be a lot of trial and error in that process without a thermal profiling system in your arsenal of tools. The types of sensors commonly used are thermocouples. They're quite handy device in that they don't require a power circuit. They actually generate small millivoltages that are predictable in engineering lookup tables, millivolts per degree. So we, for instance, use K-type thermocouples. Teflon is the most common insulation style because of its cleanliness, its ability to withstand over 500 degrees Fahrenheit, and 3-foot and 7-foot lengths are quite common. We'll discuss the reason for both. The electronic data recorder itself we call the M.O.L.E thermal profiler. We'll get into the differences there. Some of you will recognize one or the other. Because in thermal profiling we're traveling with the product through the oven or within the entire bake cycle, to protect the electronics, we run through a stainless steel barrier. Once again, cleanliness in mind, very clean one-piece designs, gets you through, gets you out, gives your M.O.L.E investment a long life, decade or more. Calipers. When you're using thermocouples, it can be handy to have a caliper handy to measure the bend point where you are going to insert the thermocouple into the dough, such that you're not introducing variability into the process yourself, minimizing that to the extent possible by marking, for instance, 1/2 the depth of what a sprung loaf, for instance, is going to be in height. So if you're 4.5 inches, you would want to go in approximately 2 1/4 inches. Mark that with the caliper and create a slight bend in the flexible thermocouple wire and make those insertions. And some handy accessories that you'll come up with and perhaps already have for organizing your thermocouple wire lines, because quite often you're making a profiling rig that extends across the breadth of a conveyor that can be 7-12 feet wide, what have you. And magnets sometimes are handy as well for organizing thermocouple wires. But also keep in mind that we furnish these winding sticks, so for the amount, so you only need to play wire out of the thermal barrier in the lengths desired. And while we're on the topic, it's important also to run the thermal barrier a certain distance behind where you have your thermocouples placed, in some cases where that is possible. But there's a lot of convection in most ovens these days. The next item needs something to document the process, so software is an integral part of the solution. And for those of you familiar with M.O.L.E Gold or BakeWATCH software, the new MAT3 software is downloadable for free on the website at all times. ECD always posts its latest software plus support for previous versions on our download site. So M.O.L.E Map 3 it's called. We'll focus on the baking environment today. Of course, computer to run that on. Consider where a free PC is available. Chances are it's not around the oven. But if you're doing a lot of profiling, let's say initially to qualify everything, the current version of our M.O.L.E, the Gold 2, has multi-run memory, so it leaves you less tethered to the PC, as long as you leave time to cool between each run, as always. So that is the newer profiler can save multiple runs, so you don't have to download after every run where that makes sense. Of course, the stainless steel box is going to be hot, and you're used to handling hot things when you're doing tests, or sometimes having to fix a conveyor jam or whatever it is. But suffice it to say, the stainless steel barrier will be rather hot, and so having at least one glove, if not a pair, comes in quite handy. So quite a lot of stuff. Most all of it comes with the kit, though, and then the things that you are used to using on the floor can help augment the kit. Mentioned if you're doing a lot of cooling back to back, 20 minutes you'll typically be cool enough to run again. But upon retrieval, you're taking the M.O.L.E out of the barrier to walk it to a computer or walk it to your next assignment. Don't forget the thermal barrier. If you do have a box fan somewhere in the vicinity, it helps it return to room temperature before the next run, and that is important in order for the M.O.L.E to have the most advantage from that thermal protection. So a couple points about the current generation of thermal profiler here. Everything's USB 2.0 now. No serial adapters required. Charging, setup, and download all through the USB 2.0 port. Another key feature is that a thermocouple condition LED is very handy. Keeps you from wasting time with a bum thermocouple that's just been used for over a year or something. It's worn out. It's opened up at the end, or something else. If it's bad, it'll show red as these open empty slots indicate. If they're inserted in green, then you're good to go. So that helps you save time. There are a number of indicators for telling you the M.O.L.E is cool enough to use, that the battery is charged enough to use, and we've separated the power and record buttons as well. So it's very easy. There's no trepidation involved with shutting off after a run. You're not going to be losing data. All right, and so the software that the profiler reports to is all important, and that's really where your hard work and expertise out on the line to obtain the data is realized. So this is a peek at the new, quite new baking environment within the ECD software called MAP. Okay, so let's look at some definitions. Time temperature profiling. It's all about time and temperature, creating a curve, creating that window into your process. And terminology profile, the term profile is actually used for two things in baking, we've found. First of all, from our prospect, the profile is this graphical plot, whether it be inserted thermocouples in the dough, product profiling, or air profiling, and often a combination of the two. But in addition to that, it's really an oven, a representative of your oven profile as well. Many of our customers call the data from the M.O.L.E an oven profile. Other industries call it a recipe. So the oven profile then helps you develop the actual oven settings. Here are zone temperatures here. In each zone that's either quantifiable by a discrete area that's individually controllable, typically, or simply dividing the length of a very long oven into even dimensions. Yes, even dimensions, which can be units of time. So that those oven settings is the oven profile. Because after all, okay, so first of all, the Y and X axes, temperature and time, because after all, the recipe is what you consider the ingredients mix of your baked goods. So this is to orient us with the data output, which is the goal of your profiling endeavors. So here we have, I mentioned the zone temperature set points up across the top. Conveyor speed is this little call out here, which is optional. You don't have to have it showing. Some people don't. There is that option. And our signature S-curve calculations that are automatic, that can save you 15 to 30 minutes alone doing the calculations of when, for instance, the yeast that you're using or some other active ingredient, when it becomes deactivated at the temperature that's reached on this line, and how far into the process from the start it becomes, and similarly the gelatinization, and then when that area of the dough reached bake temperature at arrival, which is still prior to the end of the bake cycle, of course. All right, so we talked about what are you doing today? Is it oven balancing? Is it product profiling? We'll touch on oven balancing to begin with. This is where it would make sense to use long thermocouples, 7-footers. The profile rig is typically rather centrally located on the belt, and of course different plants have different mechanisms leading up to the oven. Often there's a transfer conveyor from a proofer, for instance. But sometimes you have direct access to the front of the oven, as we see here, front end loading. And you would simply take, if you're actually doing oven balancing with a load like this, you would probably want to use half and half with the 6 channels available to you. We do have 20-channel profilers as well, by the way. 6 being the most popular, you would have 3 in the air, which we'd have wrapped around a strap bar and pointing up a couple inches above the loaf, left, center, and right, to get that lateral balancing effect across the oven, allowing you to make the adjustments internally, not only to the burners but to the colorators and venting to gain evenness across, which is called lateral balancing. So with 7-foot thermocouples, you have a breadth of up to 14 feet in width, with the profiler being somewhat in the center. Okay. So with that, with oven tuning, you're able to take a rather out of tune oven in this sequence that hopefully you're seeing here in this GIF of bringing the arrival time of the left and right channels into very tight agreement while you're balancing the actual oven ambience internally with the 3 air sensors at the top. So go ahead and look at study the air temperature evenness that results, also energy savings. Ultimately, the temperatures are a bit more moderate too to accomplish the same baking results. But we have a nice S-curve at the end of these this 3-picture animation here. That's an example of someone expertly using a thermal profiler to tune their oven. So baked goods optimization is the second realm besides oven tuning for your thermal profiler. Sure, you can use 7-foot for this. 3-foot lengths might be a bit more practical, because oftentimes what you'll do is to grab a pan, if it's buns or biscuits, cookies, that type of thing. In this case, a bread pan strap. Simply yard out the dough out of one of the pans. That'll be the home for the thermal barrier and the M.O.L.E. And make your thermocouple placements. Again, quite often in this configuration, what is commonly done is to have two air thermocouples, again wrapped around a bar in the middle here, pointing up above the dough, and that gives you the other 4 channels remaining for dough insertion. Example of hamburger bun, same idea, different product. You'll notice clips employed on the edges here for holding the air sensors up at the left and right edges of the pan. This pan is moving from top to bottom here. And a M.O.L.E, there's 2 camps of thought: vacating the area where the where the barrier is going to reside, or just leave the dough there to help anchor the barrier to keep it from sliding around. So you'll see photos of both, and that becomes a preference of what your plant dictates. In this case, we saw clamps. In this case, little disc magnets are used, and again, it depends on the rules you have in your plant, what foreign objects, as it were, you're presenting into the oven. But certainly anything metal is going to run through the detectors, and magnets such as this for organizing thermocouples, first of all, help strain relief the placement of the very tip of the thermocouple, which is where the sensing is done. That's the point that measures where those 2 dissimilar metallics come together in a bead called the junction. That's where you're measuring, and typically you want to be in the center in both depth and if not longitudinally, depending on the orientation of the dough in the pan, and into the baked good. So this is a photograph giving you some more details here. Getting ready to make that profile run. When you're doing this, it's very important to consider safety, and you don't want to be doing it alone either. You know, some of these ovens are very large. You don't want any downtime, certainly. You want to coexist with production when you're doing this work, unless it's, of course, a maintenance cycle during downtime for the oven. So always talk with the operator of the machine. Let them know what you're doing. They're the expert in operating the oven. Perhaps you are as well, perhaps less so. So it pays to think ahead and place your profile rig pan. If there's a grouping conveyor, do that first and stage it so that it will slot into the center of the oven's conveyor with your wires as neatly organized as possible, with the barrier not cantilevered at an angle that could catch on the oven entrance or exit of a large tunnel oven, such that you'll have a smooth day.
Yeah, just a comment to add to that. I've seen some of these baking ovens are quite old, 40, 50 years old, and the safety concerns they had when they were manufacturing them back then weren't nearly as restrictive as they are now, and so you could some of those old ones are man-eaters for sure.
And on the other hand, if you're running a plant full of rotating shelf ovens, it's a matter of again coexisting with production and selecting a shelf and running thermocouples up to a top shelf and then also to a shelf near the bottom as well. So you're measuring the consistency to look for variables dependent on the oven type. So this is just some more detail here. Some bakers consider the bake cycle start at the time the loader bar pushes the shelf of pans out of sight, and then with the stop time being when the unloader bar pushes the shelf pans onto the discharge. And it's extremely important to never leave the oven during a profile, because otherwise there are periods of too much excitement after a longer period of boredom. So it's good to stay in the area and definitely retrieve the profile rig as soon as it is safe, as soon as it is possible, and before it gets to the depanner and it's too late and you'd have to do an auto stop. Another good angle on a front access oven here. You see that in this case they were simply able to pull a strap, pull dough out of one of the pans. These, interestingly, are running longitudinally rather than across. I think we see them in both directions. In any case, thermocouples are going from left, center, and right, again, to cover the breadth of the belt. Another picture to remind us that you don't want a medusa of wires flying about, so placing them around underneath the pan. Unwind only as much as you need, first of all, before starting to log and closing the lid here. In this case, it appears that they use the 6 thermocouples, 2 each dough insertion, and here's an air channel here, the blue in between the straps here, and the green channel in between the straps that's wrapped around a bar here and sticking straight up. Very easy, very quick. You do that ahead of time, set it down, off you go. Straining and reliefing the wires, though, is important so you don't have any pullouts and resulting in data that you can't use. So here's a photograph of the dough just left in place to just simply hold the barrier where you want it. You give the dough a bit of pinch on the top to around the wire, such that it doesn't create an area for excess outgassing and unreliable data. During oven spring, when you have a lot of outgassing going on and expansion. So you've run it through. You've successfully picked the pan out at the first available and safe opportunity for retrieval. So the barrier is going to be hot. You're going to have a latch to flip open. You want to just, with a gloved hand, pick up the barrier. There's a grab handle as well. And pull that out. The thermocouples will come out with it. Take the tray and discard the pieces unless you're going to do some other testing. And again, the mold is going to be hot, but still touchable without gloves. Just watch out for the stainless outer enclosure. When you press the record button again to stop logging, then the unit's still on, of course, and typically the red LED will be on here, indicating that we're over 40 degrees C. It's important that this shut off before running it again. So again, it's good to 85 C. It's the job of the barrier to keep it cool and again give the mold a long life. So pay attention that this light's off before you run it again. In this case, note that all 6 channels remain good during the run. All LEDs are green here, indicating continuity for each of the 6 thermocouple sensors. So your next step is to take the M.O.L.E somewhere to download its data and place the thermal barrier somewhere safe and cool, ready for the next run. There is an alternative to using traditional thermocouples. You see two exact alike profiling units here. On the left side, we have the thermocouples that we've been talking about, individual thermocouples inserted with various measurement techniques and voodoo and otherwise, and then a single probe alternative with an air sensor at the top, a stop top here, which rides up with oven spring and expansion, and 5 thermocouples built into a sharp stainless steel shaft that gives you a consistent dough insertion depth range each and every time. It's something called the Breadometer. And what we have here is, here's the air channel, channel 1. The other 5 dough insertion sensors are able to, well, first of all, consistently give you a range of depth, telling you what areas of the dough were baked sufficiently at different arrival times. So what our software does is finds the uses the coldest spot in the dough, the channel that took the longest to reach arrival, and calculate the S-curve data here. So this can remove the operator from the equation in terms of inconsistency of thermocouple placement, saves time, and adds reliability to the data. Otherwise, the same software is used. So once again, we have our yeast kill, gelatinization, and arrival lines. We have our process origin, process end. And as we move on, we add our X and Y axes. The air channel giving us our oven line. And the other 5 insertion thermocouples, the coldest of which we calculate this data on. So from the start to yeast kill reach, it's 54%. As you see, gelatinization is usually follows within about 10% or so on its heels. Arrival time, you want typically around 20% of the bake cycle remaining, and prior to the end of the cycle here. So you can study this when you receive your slide sets. Start and end temperatures are as you define them, but really the process window, the oven bake cycle itself. Yeast kill or other active enzyme ingredient is the deactivation temperature and percent of the bake time that it took to get there. Gelatinization, that is when expansion stops, essentially. Follows on the heels of yeast kill. And arrival is defined when any channel reaches desired bake temperature, but in the case of S-curve calculation, it's based on the coldest channel. That is the one that took the longest to reach the desired bake temperature. So that's what's all calculated automatically with our software. In this case, it was channel, the third insertion channel, channel 4. Channel 1 being the air channel. So if you use this, you always want to at least you either have a breadometer, or with traditional thermocouples, your channel 1 sensor is your air channel. And again, this is what you're striving for here. If we looked at a time lapse of bread baking, various areas from a vertical standpoint are going to get baked and get this proper cell structure sooner than others. And this is what we're finding. This is what you are tasked to find for increased reliability and product quality, product consistency from plant to plant, all of this. It's quite easy to calculate. Small tweaks in yield can become apparent, and increasing that by several percentage points will add to your bottom line significantly and measurably in short order, and certainly justify the use of profiling equipment. And also stalls and returns from your retail distribution. As you have successfully implemented active enzymes for increased shelf life, those logistical and production expenses will be cut markedly as well. So you'll be the hero there. So today has been an overview of thermal profiling for baking. We'll have subsequent classes, especially those involving the meat of the software in more depth. And we thank you very much for your listening today. Please visit our website.
Thank you, Ray. Again, thank you for attending this ECDU. This class will be available on the website for your viewing pleasure later in the week. We've used up almost all of our time, but we are going to unmute the phones. If you have questions, you can ask them now. The spreadsheet that Ray showed before on bakery yield and cost realization can be downloaded from the website at www.bakewatch.com if you're interested in looking at that further. And if you're interested in taking any further ECDU classes, please visit the website www.ecd.com/ECDU.